It's David again. Now that we know how to do truth tables, let's step it up a notch. So one of the probably the first problems you'll see in these discrete structures, discrete logic problems, is the and. The and is denoted here by the little like caret, the upside down V looking symbol, and it roughly translates into English as the and. So like a statement that you could transform into the and logic issue would be like the sky is blue and the Eiffel Tower is in France. So when I use the and, that means that both statements have to be true in order for the whole statement to be true. So an example of a false and statement would be the sky is blue and the Eiffel Tower is in Russia. So the sky is blue is true, but because the Eiffel Tower is not in Russia, that means the whole statement would be false. So in computer science, if you're programming or you've seen programming before, you've probably seen the double ampersand sign in if statements or something, and that is related to the and in these truth table problems. And additionally, some people have used this kind of like in math. An easy way to think of this is if like true is a 1 and false is a 0, and is a multiplication. So if you have one false, everything is false. Much like in a multiplication problem, if you have 1 0, everything turns into 0. So now that we know that and we've done a truth table before, let's break out the truth table and prove this. So as mentioned before, we're doing P and Q, which is two variables. So we know that over here, we're going to have a grid that is going to have 2 to the power of 2, because there's two variables. So we're going to have 4 rows. 2, 3, and 4. And working right to left, we know that this one is going to be 2 to the power of 0, which is 1. So we're going to have 1 true, 1 false, 1 true, 1 false. This next one is 1 over, so counting from the right side over, this is going to be 2 to the power of 1, which is going to be 2. So we're going to have 2 true and 2 false. Great. So we have the original table that we're going to use to prove this. So the question we have to graph out is P and Q. Goodness, I should have drawn this a little bit earlier. All right. First one, we have a true and a true, which makes the statement true. If we translate this in numbers and then we have 1 times 1, that's going to be equal to 1. So this is going to be true. Next, we have a true and a false. Just like we just talked about, this is going to be false because one of them is false. Once again, if this was numbers, we'd have 1 times 0, which would be false, or 0. So false. And here we see that all the remaining p's are false, which no matter what is going to make the whole statement false. So we'll go ahead and mark that out. Great. So that's the statement for P and Q. So what if we wanted to do this with, say, 3 variables? So that would be the same. We would just add on an additional row. So let me draw this out real quick. And as we talked about earlier, for this statement to be false, we just have to have one F. In the first line, there's no F's, so that means this is true. And if we look, we can see that in every other line, there is at least one F. So we could go ahead and compare them all, but I feel safe just marking that as F. Great. So that is P and Q and R in a logic table. Finally, I wanted to switch one thing, and that would be instead of us having P and Q and R, I just wanted to compare just two, even though we're in a three variable truth table. So if I wanted to do that, let me bring that back, erase this. But then we're just going to have P and R. So this is going to be the same, but we're only comparing the P and R value. So even though there is a three variable truth table, we can still operate on only two if we want to. So we can see here just P and R, this is true. P and R, this is false. That's an F, so that's false. Here, though, both P and R are true. So that means this is going to be different from having the P and Q and R, because if P and R are both true, the whole statement is true. And then we can go ahead and see from the rest of it that the rest of the lines are false. So in this video, we went over the AND statement. We did it with a two variable table, and we bumped up to a three variable table. And that's the AND statement in